Hello everyone. Let me demonstrate the 17th activity in the lab manual of class 12th. It is the maximum area of the rectangle. The objective of the activity to find the time when the area of a rectangle of given dimensions become maximum if the length is decreasing and the breadth is increasing at a given rate. Material required: colored sheets, pencil, ruler, calculator, adhesive. Let us see the method of construction. We take a rectangle R1 of dimension 16 centimeter by 8 centimeter. Now, what we are going to do is we are going to reduce the length of the rectangle by a certain fixed number and increase the breadth again by a certain fixed number. That fixed number can be 1 centimeter per second for the length. So let us reduce the length every time by 1 centimeter and increase the breadth by 2 centimeters for every second. So if we had 16 centimeter and 8 centimeter, this next rectangle R2 is going to be 16 reduce it by 115 and 18 increases by 2, it comes to 10. Next, 15 reduced by 1, 14, 10 increased by 2, 12. Similarly, R4 will be 13. After 3 seconds, we'll get R4, 13 centimeter, increase 12 by 2, 14 centimeter. Similarly, after every second, after 1 second, we get R2, after 2 seconds, R3, 3 seconds, R4, 4 seconds, R5, 5 seconds, R6, 6 seconds, R7, 7 seconds, R8, and 8 seconds, R9. And correspondingly, the dimensions are going to become 15 by 10, 14 by 12, 13 by 14, 12 by 16, 11 by 18, 10 by 20, 9 by 22, and 8 by 24. This is going to be figure 17. Now, what is figure 17 going to be? We will just paste the rectangles on the colored sheet. Now, for that, the easy thing can be that you take a square sheet or a graph sheet. Now, this kind of a sheet can be taken. It becomes very easy for us to draw the rectangles and then we can color it. Instead of cutting it out and pasting, I would suggest that you just simply take the first rectangle, let's say R1. R1 was 16 centimeters by 8 centimeter. So I'll take this length 16. If I take the scale as 2 centimeter equal to 1 unit, I'll take 8 squares from here and 4 squares the breadth, and I'll be getting a rectangle of 16 by 8. So this is going to be the rectangle R1. This is 8 squares by 4 squares. So I get 16 by 8. Similarly, R2, 15 by 10. So I'll take 7.5 squares like this and 5 squares like this to get a rectangle of 15 by 10. Next, R3 is 14 by 12. So I'll take 7 by 6, 7 squares length and 12 and 6 squares breadth. R4 is 13 by 14. Exactly same way I'll be drawing it. R5, 12 by 16. R6, 11 by 18. R7, 10 by 20. R8, 9 by 22. R9 is going to be 8 centimeter by 24 centimeter. That is the last rectangle that we are drawing. So 8 centimeter means length of 4 squares and breadth of 12 squares. So demonstration, let us go on to that. The length of the rectangle is decreasing at the rate of 1 centimeter and the breadth is increasing at the rate of 2 centimeters per second. Every 1 second, we are reducing the length by 1 centimeter and increasing the breadth by 2 centimeters. So the area also changes accordingly. Area of the first rectangle R1 was 16 into 8, that is 128 centimeters square. The area of the second rectangle R2 will be what? 15 by 10. That is 150 centimeters square. Area of the rectangle R3. R3 is what? 14 by 12, which is 168 centimeters square. R4 is 13 by 14, 182 centimeters square. R5, R6, R7 is going to be after 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. R7 is after 6 seconds, 10 into 20, which is 200 centimeters square. This is after 6 seconds. R8 is what? 1 less 9, 2 more 22, 9 into 22, 198 centimeters square after 7 seconds and so on. So this is the table we've gone, and clearly from this we can say, well, how much is the maximum area? The maximum area 128, 150, 168, 182, 192, 198, 200 and 198. The maximum out of these is this area. The area of R7, which is coming out to be 200 centimeters square, and it is after 6 seconds. So using this, we are going to fill up the blanks that are there. The observation, area of the rectangle R2. R2 was what? Reduce 1 from the length of the original rectangle, that becomes 15, and add 2 to the breadth of the original rectangle, which becomes 10. So you get 15 into 10, which is equal to 150 centimeters square. After 2 seconds, you got R3. After 3 seconds, you got R4. And from whatever we had found out, we can write out the answers. For this, the area we'd already found out. The rectangle of maximum area came out to be after, if you remember, it came out to be after 6 seconds. And that was how much? Which rectangle was that? That was R7. The area of the rectangle is maximum after how many seconds? It is after 6 seconds. And the maximum area of the rectangle was how much? It came out to be 200 centimeter square. So let us just verify what we have done is correct or not. This is not to be done in a lab file. This is just for explanation. You know the length and the breadth of the rectangle, if I suppose them to be as A and B, we had taken them to be as 16 and 8, if you remember. I take it to be as A and B. Now, because after every second, the length is reducing by 1 second. So at t seconds, the new length is going to become how much? It's going to become A minus 1t, right? Exactly same way, the breadth is increasing by 2 seconds. So after every t seconds, it's going to become B plus 2t, isn't it? Now, this is the new length and the new breadth. So area after t seconds is going to become how much? It's going to be the new length into new breadth, A minus t into B plus 2. If I multiply that, how much do I get? It comes out to be AB minus BT plus 2AT minus 2T square. Now, A dash T is what? If I differentiate this, I get this becomes 0 minus B plus 2A minus 4T. This is A dash T. Now, when will the area become maximum or minimum? It's going to become at A dash T when it is equal to 0. So, if I put this equal to 0, what do I get? That means minus B plus 2A minus 4T is equal to 0. So using A is equal to 16 and B is equal to 8, I get minus 8 plus 2 into 16 minus 4T equal to 0, which gives me 4T is equal to 24 or T is equal to 6. This is matching with what we had got in our observation, that at T is equal to 6, the area is becoming maximum. So this is the beauty of the whole experiment. So the application stands that the activity can be used in explaining the concept of the rate of change and optimization of the function. I can find out that where will the function become maximum or minimum after a given time. So I hope you have liked the activity, and in case there's any doubt, just go back and watch it again. Thank you so much.